I'm Anil Kumar, and in this particular video we'll explore how to find equation of an exponential function from the given graph. Now here are two simple graphs for you, and then we'll figure out how to find the equations of these graphs, right? So let us say these are the x's, and let me sketch one, and let's say this one is one of the graphs for us. Okay, it's approaching 0 as the exponential function should, and kind of like this. In this case, let's take a function kind of like this. Okay. So we have two exponential functions. These are indeed exponential functions because their domain is all real numbers, and we have a horizontal asymptote, and the range is greater than 0. So these are the characteristics of exponential functions which we find, and we also see that the function is always increasing or always decreasing in its domain, right? Now to start with, let's start with a very simple value. Let's say the y-intercept is 1. Now my question to you is that if this is the x-axis and that is the y-axis, and if I say y equals to log ax is, it is an exponential function, so I should not be writing y equals to log ax. I should be writing y equals to a to the power of x. Perfect. So remember that part. We are doing chapter on logarithmics and exponential equation, but be careful. Log is inverse of exponential function. Okay. So be careful about this. So this is an exponential function. Now my question to you is that the equation should be something like this for this particular graph. Now what could be the values of a? So you have to give me possible values of a. So in this case, what do you think could be possible values of a? Now as you see, this exponential graph is actually decreasing. That means a should be less than 1, and as you know, a is always positive, so it has to be greater than 0. So a is kind of a fraction between 0 and 1. So these are all the possible values of a. Now to find specific value of a, we actually need to have a point on the graph. Otherwise we can only give a general equation, right? So let us say that we have a point on the graph, and let's give this some number associated with this point, and since it is on this side, let me say the point is minus 3, 8. So if I say that the point P exists on this curve whose coordinates are minus 3, 8, then what is the equation of this exponential function? Now using this point, we can find the specific equation which we are looking for. Now in that case, we know that y equals to a to the power of x. X and y values are given to us. So we can write y as 8 and x as minus 3 and then solve the equation. Substituting these values, we get, let's begin with the equation itself. Y equals to a to the power of x. Y is 8 and a to the power of minus 3 should be 8. So that is the equation which we need to solve. Correct? So when we say a is minus 3, you could think about writing this as, we could write this as a cube equals to 1 over 8, right? Or a is equals to cube root of 1 over 8, and that clearly is equals to 1 over 2, correct? So cube root of 1 over 8. So from here we can get our equation, and now let me write down the equation of the given exponential function where the point minus 3, 8 lies on the graph of the function. So since a is half, we could write this as y equals to half to the power of x as the exponential equation for the given graph. I hope that part is clear to you, right? So in the first example, what we did was we took a very basic function. Now we will kind of add one more dimension to our question and say, now let us figure out how to find equation of a graph in the form of y equals to, let us say, c times a to the power of x. That means there is a stretch factor. Okay, so we'll have a graph where I like to take this point as not 1 since it is getting stretched by a factor. So let me take this point as 4. Okay, so that means stretched by a factor of 4. And let us take another point on the graph itself, which could be, okay, we'll name it later. So first, as we started in the previous case, if I have y-intercept of 4, in that case, what are the possible values of a and c? So in this case, c should be equal to 4, right? Since x to the power of 0, since this point here is strictly speaking 0, 4, right? So if I write 0 here and 4 there, so let me write down and show it to you how really we get the value. We could say 4 is a y value, so 4 is equals to c times a could be anything, x is 0. Now anything to the power of 0 is always 1, so we get 4 equals to c. So c equals to 1, c equals to 4 is for sure. Now my question is, what could be the values of a? Now as we did last time, here it is exponential growth, correct? Since it is exponential growth, a value should always be greater than 1. So we can say at least a is greater than 1, correct? So that is what we can say at this stage. Perfect. So I hope you understand the concept. When we are looking at an exponential growth, a should be, the base should be greater than 1. But if it is a decay, it is between 0 and 1. As you know, a cannot be 1. In that case, you just get a horizontal line, right? Not an exponential growth. Okay. Now let's take another point. So let me take this point in this case as 2 and 36, for example. Okay. So 2 and 36 is my point on the graph, and we need to now find what is the value of a. We already know c is 4. So since c is 4, let me write the equation now as y equals to 4 a to the power of x, and the point given to us is 236. So we'll substitute 2 for x and 36 for y. So we get 36 equals to 4 times 8 square. So dividing 36 by 4, we will get 9, right? And here we are writing a square. So let me take all these things to the right side to solve it further. Okay, so we have a square equals to 9. So a should be equals to square root of 9. Since we are talking about the base, a is always greater than 1. So we should neglect minus 3. We'll only take 3 as our value. So a is equals to 3, right? Since a is 3, our equation will become y equals to 4 times 3 to the power of x. So that exponential equation now represents the given function. Is it okay? So that is how you can actually find exponential equation for the given graph. I hope it helps, right? So we'll further take few more examples on finding equation from the graph, where we are going to involve vertical translations and horizontal translations. I hope that helps. Thank you and all the best.